Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Muhammad Adam Haris Muhammad Fadil and I am from Group 6. Today I will introduce you about what is Pennsylvania Truss structure. Pennsylvania Truss structure has been developed from the Pratt Truss structure. This Pennsylvania Truss design gained widespread acclaim for its capacity to achieve extended span with optimal material usage. Not only serving as a vital component of the local transportation network, but it also has a significant chapter in Pennsylvania engineering history.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Akiafi bin Muhammad Nazri and I'm going to present about background of study case. So, first of all, this is a picture of Pennsylvania Truss Bridge. So, as you can see, there are many external force that was applied on each member, some of a member. So, for example, there are 80 kilonewton at some of the member, and another information that we can get is there are two beam reaction. The beam reaction are from pin support and roller support. As we know, pin support have a reaction or x-axis then y-axis reaction, and roller support have a y-axis reaction only. So that is one information that we can get. Another information is that force IH have for a truss FI, there are 440 kilonewton in tension. So that is information that we can get. And another one is there are also a angle for each member, so that we can calculate it more easier and we can get the precise answer. Now I'm going to present how we want to calculate each member of truss. So what we can do is try to find an angle for each member and then draw a FBD or FBD, and then what we can do is find the external force, that is the beam reaction. So the thirdly, we can do a method of joint so that we can know each member, each member is it what kind of force react in each member, whether it's tension or compression.
Truss theory. Truss are structures made up of interconnected elements forming triangle. Triangles are stable geometric shapes, and the arrangement of this triangle in truss provides strength and stability to the overall structure. Load distribution. The Pennsylvania truss is designed to efficiently distribute load, both vertical and horizontal, across its member. The diagonal and vertical elements work together to transfer force and maintain equilibrium, ensuring that the bridge can support its intended loads. Material efficiency. The design aims to use material efficiently by creating a network of triangles. The Pennsylvania truss minimize the amount of material needed to achieve structural integrity. The efficiency is crucial for economic and engineering reasons.
Okay, now I will talk about engineering application. As we can see here, this is a picture of Eastern Phillipsburg Toll Bridge. We can see that this Pennsylvania bridge is very long, that can cross the river without using many pillar. That show that this Pennsylvania structure is very good for a long distance, like river or by river lah actually. Aku lupa nak cakap apa. Fuck. Okay. Now I will talk about engineering application Now I will talk about engineering application of this Pennsylvania truss structure. As we can see at here, that is a Metropolis Bridge and Eastern Philipsburg Toll Bridge. These two bridges has been used in the long distance. Like we can see at Eastern, it has been used to across the river, and at Metropolis, that is actually a river too, but this is the side picture of that Metropolis Bridge. For the historical context, this Pennsylvania Truss design has been found in late 19th century. The founder of this Pennsylvania Truss structure is Wilson and Henry Pettit of the Pennsylvania Railroad to the design of Iron Truss Railroad Bridge in US. Wilson and Pettit developed statically determined through form, connection detail, and detail of built-up compression member that were widely adopted by other US bridge designer. We can see at here that Pennsylvania Truss structure can be built without need many pillar. That can show us. Tak boleh pula. As we can see here, this Pennsylvania Truss structure bridge not using many pillar that can less the river traffic, and we can less the cost. Also, this Pennsylvania Truss structure is very strong that can accommodate a railway and a road bridge.
Assalamualaikum warahmatullahi wabarakatuh. And now I'm going to present about analysis and calculation. Okay, first of all, we should draw a FBD so that we know what force that react on it, what angle for each member, and what kind of force that apply on some of the member. So first of all, draw it, and then try to find unknown angle or unknown. Try to find the unknown angle first. Now we're going to find the external force, that is the beam reaction, so that we can know what kind of force that was applied on that joint. Okay, now we're going to do a method of joint. Okay, first of all, we should draw FBD. But for this question, since the bridge is mirrored, so to make our calculation more easier, we should take the other half, and the other half we can assume that the other half is also the same. What the reaction on each beam on the other half is the same as the other half. So from this, I start to calculate the joint A first, so we can get a truss A reaction. After that, we calculate joint B, and then we calculate the joint N, and then we calculate joint C, joint T, and joint O. For this, I want to tell you that there are some part that is mirrored, so we assume that what reaction that happened there is the same as the other half. And then we calculate joint E, F, and G. After that, we calculate joint U. And lastly, we draw back the bridge, and then we list down all the reaction that happen on each truss, that whether it is tension or compression.
Engineering characteristic. One notable feature of the Pennsylvania truss is its efficient use of material in a triangular truss configuration. The agreement of diagonal and vertical members form a series of interconnected triangles, providing stability and strength to the bridge. The design was particularly well suitable of a railroad bridge due to its ability to span long distance and support heavy loads. For material and construction, Pennsylvania truss bridge were often constructed using iron or steel, material known for their durability and strength. The use of this material allowed for the construction of robust structures capable of withstanding the demand of heavy train traffic and adverse weather conditions. The process of assembling this bridge involved careful engineering calculation to ensure the structural integrity. For evolution of bridge design with advancement in engineering and technology, bridge design have evolved. While Pennsylvania Truss Bridge were once ubiquitous, modern design may prioritize different considerations such as aesthetic, environment impact, and construction method. The evolution of bridge design reflects changing engineering priorities and the integration of a new material and construction techniques.
For conclusion, we notice that a crucial component of structural engineering is truss analysis, which assesses the stability strength and engineering performance of the framework. The frame was widely used in buildings, bridges, and other construction. It was made up of a straight member joint at the joints in a triangle arrangement. This is because we can say that when a force is applied to one of the corners of the triangle, it is distributed down each side. It is essential to comprehend the main components of the truss, such as joints, members, and external load. Okay, other than that, we can say that tension and compression tests are used to analyze how truss parts respond to different loads, including their ability to endure pulling forces and compression. Internal forces within the truss, such as axial internal and external forces such as applied loads and support ratio, also taken into an aspect when assessing our structure. Lastly, the type and amount of the load acting on a truss structure is an important factor to consider when analyzing it, and this includes the dead loads, live loads, and environmental influences. This consideration is crucial to entire analytical process in order to analyze the effect of this load on the truss member and overall state of the structure.